Alright everybody, happy Friday. Here we are again, another math lesson coming at you. Here are the answers for 12.2, surface area of prisms and cylinders. Here's everything for you. Check your answers. There's not a lot, folks, so hopefully the homework didn't take you a whole lot of time. Had a good couple questions, and I tried to answer them as quick as I could, but yeah, your homework's looking good. Everybody keep doing your homework. And I want to let all of you know that I've been watching Sesame Street a lot lately. You know, with Levi being 1 year old, and you know we got to throw something on the TV every once in a while. So we throw Sesame Street on, and I'm starting to get all the little jingles and all the songs. And there's always a number of the day. I love this. I got the song memorized. No, I'm not going to sing it for you, but I'm going to give everybody a number of the day. Check this out. Ready? Your number of the day is 5. Now, what does that 5 mean? Well, there's a reason why there's a 5, the number of the day. That 5 is the total number of videos or days that we have left. Let that sink in for just a moment. We have a Friday, we have a Monday, a Tuesday, a Wednesday. Wow, back up. Friday, Monday, Wednesday, Friday. The following Monday is Memorial Day, so that doesn't count. So then Wednesday, which is the thumb right here, Wednesday is the last day. I believe that's May 27th. So it's coming quickly, folks. Please finish this class strong. Finish your other classes strong, for that matter. And, you know, we'll be good. Then we can start summer off on the right foot. 12.3, here we go. Go ahead and get your notes out, and let's fly. Surface areas of, what should we learn today? We did prisms and cylinders already. Let's do pyramids and cones. Pyramids and cones. Chances are you know what these geometric figures look like. Everybody's seen pictures of the pyramids in Egypt. Those are pyramids, square pyramids, as we like to call them. And then cones, if you've ever been to an ice cream store, it's an upside down cone. You guys get the picture. We're going to be drawing these. Let's go ahead and get started. I want to start off with pyramids. And 2 things I want to let everybody know. Yes, I got my phone in front of me. I'm not going to have to search all over the house for 2,000 years to find my phone. And second of all, I want to make a shout out that today, Friday, is Kristen Haas's 16th birthday. 16. So if you're friends with her on Snapchat or Instagram, shoot her a message. Tell her happy birthday. That's a big age. So happy birthday, Kristen. All right, let's get started. Pyramids. Let's draw. Oh, what kind of a pyramid are we gonna draw? I want you to draw a square pyramid. So let's get started. I want to do this right, so let's go here. Everybody, here's a square for you. It's a pretty good looking square, huh? Mr. Kosal, you're out of your mind. That's not a square at all. I want you, because we're drawing a 3-dimensional figure, I want you to look at this like we're looking at a pyramid sideways, you know, from a sideways perspective. Now, this is how I like to make my pyramids. I like to find the center point of this base, the square base. Looks like a parallelogram. It's a square from the side. But I'd like you to find this point. I'd like you to go up, 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 and let's go up a little higher. Let's go right there. And then, let's see if I can get my ruler out. I'd like you to connect it with that front right vertex. Do it again. Connect that top point to this vertex down here. Alright. Same thing again. Got some smearage right there. A little bit of smearing of the ink. Connect the top point down here. And then this last one, I want to make it dashed because that's an edge that from our perspective we cannot see. So see, I'm going to make that little point right there. But we know the edge is there, so I'm going to make it dashed. There we go. Folks, we got your square pyramid. Hopefully you can visualize it now. Pyramids have a base, which I'm going to color code this. I like what I did on Wednesday, color coding my prisms and my cylinders. I'd like you to color code this bottom, please. If you don't have a color pencil, find one in the house. Find a highlighter. Find anything that can give your notes some color. But this right here, that the pyramid's kind of sitting on, this is the geometric figure on the bottom. That's your base. Let me go over that with black pen. That is hard to see. That's your base. Now, folks, it could be any polygon. It could be any polygon. It could be, for example, in this example right here, it could be a square. But it could be a hexagon. It could be an octagon. You know, there's tons of polygons that we can have for the base. We just know the square pyramid because of the square pyramids in Egypt. But there are hundreds of different pyramids that don't have a square as a base. We call it a hexagonal pyramid. We call it an octagonal pyramid. You can have a triangular pyramid where the base is actually a triangle. But it could be any polygon. So that's the base. Let's see, what else do we have here? Okay. These triangles, which are the lateral faces going up to the top. Here's the front one. And then you got this side one right here. That's kind of hard to see. And then you have the back one, which I guess I'll kind of sketch. Those are what you call the lateral faces. And we're going to talk about the lateral area of a pyramid today. And it's pretty much adding the areas of all these blue triangles going up to the very top. Those are the lateral faces. This right here is a lateral edge. Okay. This right here is a base edge. You know, it's an edge on the base. This is an edge on the lateral face. And then we got some interesting ones. So I need to change colors here. This little point right here, it's a very, very important point. I'd like you to take that point that's kind of in the center of my square. I tried to do the best I could to put it in the center. I'd like you to connect that point to the very topmost point. We call that the vertex. I might write that in just a second. I'd like you to connect that. And I'm going to pull this out just so I'm kind of pointing to it. Folks, this is the altitude, or Mr. Kosal likes to call the height. They use the height in the book. The altitude, or the height, is always perpendicular to the base. It's always straight up and down. It's not slanted. It's not going in that direction. It's always perpendicular to the base. And then we have one more. Actually, you know what? Let me go ahead and put vertex right here. There's your vertex. And all this definition is extremely important, folks. Extremely important. Last one. I'd like you to take this vertex at the top, and I'd like you to come down over here, find the midpoint of this side so that these two pieces are exactly the same. Find the midpoint of just one of these base edges. And I'd like you to connect the vertex at the top to that midpoint, please. So you get something like this. Now notice how it's coming down at a slant. We call this, and the book calls this, the slant height. We need to be very, very careful here. Do not, geometry students, get this slant height confused with the regular height. Here, I don't even like altitude. I want to get rid of it. Just height. That's the height. Don't get the slant height confused with the height. This is the height of the pyramid. This is the slant height of the pyramid. Very, very important. Very, very important. And the slant height, we call it L. L for, you know, I wish they would have called it S or H, but they use this L, I guess. I don't know. Slant height is going to be L. The height is just going to be H. And I think that's it. Oh, one more thing. This isn't in the book. Actually, it is in the book, but I'm just going to tell you right now. Notice how if you connect the center over to this midpoint here, does everybody see this right triangle that's kind of on the inside? of your pyramid, sometimes you need to use this right triangle. Sometimes in the problems in your homework, you're going to need to use the Pythagorean theorem to find an unknown measure. You'll see what I'm talking about in just a second. All right, that's really it, everybody. That gives you the idea of what a pyramid is going to be working with, and now I get to give you the formulas. So let's start off with LA. LA, of course, stands for lateral area. Now the lateral area of a pyramid is just going to be, well, let's take a lateral face. Let's take one of these lateral faces. Let's take this front. It's a triangle going up to the very top. So here, I'm going to make that kind of look like that. Maybe I'll even color it blue. You're going to find the area of one of these triangles. And then I guess the question is, how many blue triangles are going up to the very top vertex? 4, because you got the front, the back, the right, and the left. So multiply it by 4. And folks, that's your lateral area. You add up or you multiply the total number of triangles going up to the very top point. Now surface area, if I were to paint every surface of this pyramid, I would have to paint the 4 lateral faces, the 4 blue triangles going up to the very top vertex. And I'd also have to kind of take this and kind of flip it upright and paint the bottom as well, because that is a surface of the pyramid. So the surface area is going to be your lateral area plus a base. It's the lateral area plus a base. So in other words, surface area is going to be 4 triangle lateral faces that we've already talked about plus the square bottom. And I'm just going to make a square because that's what it is, sideways. So that is going to be your surface area. Bam. Perfect. Ready to hit one of these, folks? Think you're ready? I think you're ready. Here we go.